NIFWIF funds that are going to be partially for science of monitoring the restoration projects, et cetera. And so clearly that's an area that, in terms of understanding the cumulative impacts of restoration, one would want to look at all that science, and maybe there's a role for NAS in putting that science together, but clearly others will make a lot of investments. NERDA, we'll see how that rolls out. Obviously, the states have a large built infrastructure in things like living marine resources and water quality monitoring, primarily in the territorial seas. The federal agencies have a whole plethora of mission-appropriate monitoring that they're doing, including the Navy and others. The oil and gas industry has a major investment in what we would call operational oceanography. When they have large pipe strings out there, they need to know which way the currents are going, and particularly if they have an incident in terms of spill response, which way are those going? I actually think that's a fairly productive engagement that one could have with the industry about long-term plans. The GOMRI has obviously they have a number of funded centers. Their niche is primarily process-oriented research, and they've said that they don't want to be into long-term monitoring nor technology development for that. So obviously that lends some aspects to this. Under the Restore Act, each of the states have these centers of excellence that they will put together. This is to be determined in terms of their priorities, and clearly observing is one of them. And the Florida group, which is going to be centered at the Florida Institute of Oceanography, has as its primary mission environmental monitoring. And obviously other groups like the IUS groups in the region, GridC and NODC, have a major element of archival, data archival and management. So clearly, where is the niche for NAS is an important topic. So in terms of the current system, if I might characterize the attributes of the system as primarily ship or satellite based. It takes a ship to do a lot of the things that are being done out in environmental monitoring. It's expensive. There's substantial investment in the current systems. It's incremental, and that is, a lot of people are asking for incremental increases in one or more observing systems, and so one could spend a lot of money in any one of them. It's very rigid. All of the environmental monitoring that I know of is done with a specific purpose, not necessarily a system purpose. It's fisheries monitoring, it's operational oceanography for the oil companies, etc. The data are somewhat opaque. It's hard to find a portal of entry, particularly into the primary data, and it's sparse. Everybody's complaining that they don't have enough in terms of environmental monitoring. So what would the attributes of a better system be? Distributed, taking advantage of newer technologies that leverage the ship and satellite-based technologies but add value to them. That's cheaper. I don't mean necessarily less expensive than the current system, but cheaper per bit of information in terms of what we are investing in. It's disruptive or transformational as opposed to incremental, and that is, there's lots of new technologies out there, and personally I think that's a niche for NAS. How can we actually turn a lot of what we have as mission-based environmental monitoring into new knowledge? It's more flexible, and that is, if everybody does their thing in their own bowling alley in terms of environmental monitoring, you never get this sort of piggybacking opportunity and other things. It's discoverable, that is, the data are distributed and people can really get their hands on the data, and then it's not sparse but dense. This would be sort of an ideal set of attributes, at least from my point of view. So in terms of NAS's potential role, here I offer two items. First of all, investing in what I would call maturing enabling technologies to permit research operations. There are a lot of technologies that are on the cusp of actually addressing some of those attributes that I talked about before. Cheap, reliable, and deployable technologies, concentrating on hypothesis-driven research as opposed to mission-oriented monitoring, monitoring that you basically discover the hypothesis after you've been monitoring for a while. And then obviously there's a large opportunity here and now to partner with the operational observing agencies who are grossly underfunded to do what they want to do, particularly in terms of implementation of new technologies, and also the government-industry partnership. I think the industry itself is that actually I think they're much more amenable to these kinds of partnerships. At least that's been my experience. And last, you know, in terms of a portfolio management scheme, clearly, you know, the investment charter that you all have is over 30 years, and so if you tie up all your money early on in the system, I mean, you got 3 decades to go. So, you know, my advice would be a little bit flexible and nimble in terms of what the investment portfolio might be. Next. So, in terms of some potential monitoring priorities, I said I had a dog in the fight. Well, there's a bunch of dogs and a bunch of fights here. But as I see it, if one looks at the source of the money that's funding the NAS program, it's in a variety of things. Of course, obviously, it's related to oil spill and oil spill impacts, but also it's disaster preparedness. And I see 3 major focal areas that one might think about investing in new technologies, for example, to do this. First of all, in physical oceanography. Clearly, you know, there is a subnet of models out there that will, you know, do things like prediction of oil spill trajectories, both at the surface, and clearly we need subsurface as well, and that technology certainly wasn't available to any great degree during the Deepwater Horizon. So a more dense subnet of models that would allow finer scale predictions. Something about deep ocean currents. You know, the industry is moving deeper and deeper into the Gulf of Mexico, and you know, if we do get a repeat of a deep water blowout, we need to know what the trajectory of those are going to be, and frankly, that's very poorly developed in terms of an operational oceanographic capability. And last, deep observations. I think you may have talked about the potential for the use of the BP cable network out there and using that for science. That's one idea. There are also other potential ideas like animal-based oceanography, and I'll show you an example of what that means. Living marine resources. There's been a number of groups meeting about the notion of animal tracking, and I'll talk about that a little bit. It's a nascent network in the Gulf of Mexico, but I think it's one that's really ripe. And lastly, there's on the LMR side, the remote sensing enables technologies like and optics and acoustics. We've been monitoring living marine resources, basically using the same tools for about 100 years. And I think we're on the cusp of actually developing and implementing technologies that are less biased and probably much more synoptic. And lastly, contaminants. You know, clearly, the origin of this money is in environmental contamination. There's a huge issue in the Gulf of Mexico about what the ambient level of contamination of hydrocarbons is versus the event derivative. And this is obviously a source of the conjecture about Deepwater Horizon and other spills. And so trying to sort this out is potentially important. Next one, please. So I wanted to just motivate this with a few examples before I sit down. If one looks at deep ocean oceanography, you know, according to the realm right now are the so-called Argo floats, which are out distributed in the world's oceans. This is a screenshot from last week. Those are the positions of all the Argo floats in the world. You can see that if you look at the Gulf of Mexico, there are 9 floats currently in the Gulf of Mexico and none in the eastern part of the Gulf of Mexico. These floats go up to the surface, they go down to the bottom, they do basic profiles. So in terms of deep oceanography, it's hard to keep any of these floats in the Gulf of Mexico because of the currents. They just keep it being ejected out, and so that's a problem. So you know, clearly that's one of those areas in the world's oceans that's underrepresented by deep oceanography observations. So, and just to make the point about the complexity of the Gulf of Mexico, you see the strong loop current there. Loop current eddies form. They can go west, they can go east, etc. And so keeping something like a glider in the loop current is extremely difficult. And it's a very fast-moving current. So there have been the development of a variety of new technologies. During the Deepwater Horizon incident, we saw the use of gliders, for example, on the West Florida Shelf in the northern Gulf of Mexico. They were basically an experimental technology primarily developed by the military. I think they proved their worth. We're starting to see gliders being able to control lines and do these kinds of things. And we talked to the industry a little bit about using glider network to actually enhance the observing system, and particularly in areas of the Gulf where we don't have a lot of built infrastructure. For example, you know, oil and gas rigs where you can attach something. This is a nice potential operational technology that there's some work out there using gliders, but not a glider fleet. Next one. So use of animal tracking. This is a graphic from a paper that was in Nature by Barb Block and others. And these are basically animal tracks from a whole variety of species. You can see they're marine mammals, whales, turtles, a bunch of pelagic fishes. So the animals carry both a tracking device and a temperature recorder. And so there are tens of thousands of temperature recordings that were developed for the Pacific Ocean based on animal tracking, devices. In the Gulf of Mexico, we have many of the same species, and a really good one is sperm whales. We have a lot of sperm whales in the Gulf of Mexico. They dive down to the bottom of the Gulf of Mexico, the deepest depths, and they come back to the surface on a regular basis. So if equipped with animal tracking devices, we could get a lot of oceanography and a lot of fish biology at the same time. There was a meeting 2 weeks ago in St. Petersburg talking about a tracking network. And so there are two flavors of tracking. The active tracking, like I showed you before in the Pacific, where you attach a device to an animal that comes to the surface every once in a while and offloads data to a satellite. The other way to do this is to put out so-called tracking curtains. And what they are is acoustic receivers that are spaced about 1 kilometer apart. And you basically put a small acoustic tag on a bunch of animals. And so a number of people have thought about where would be appropriate places in the Gulf of Mexico for these tracking curtains be. And here's one example offered by Clay Porsche, who's a scientist at the National Fisheries Service. Straits of Florida, Eastern Western Gulf, U.S. border, and then obviously the Straits of Yucatan. Next slide. So what can you learn? Well, interestingly, there's a large number of hypotheses, in this case looking at fish, that you could actually sort out by tracking the animals as they move through these curtains. So for example, bluefin tuna. The Gulf of Mexico is the only known spawning region for the Western Atlantic bluefin tuna. And so understanding when they come through the Straits of Florida and up to spawn and when they leave is an important aspect in management, as well as things like red snapper. We know we have an eastern and a western stock, and understanding how animals move between those eastern and western stocks is important. So clearly we can make this hypothesis driven. Next one. In terms of some of these other technologies, I wanted to demonstrate one sort of reinventing their resource surveys. There's been a lot of work on optics and acoustics, and this is a program we have at USF to develop underwater towed cameras. And so I wanted to show you some examples from the marine protected areas that are up on the upper right panel. Next one. So if you show you a little movie here. This is from that vehicle you just saw. That's a gag grouper, a very large gag grouper there. These are the kinds of technologies that we think are going to replace things like trawls. So this is a very large school of vermilion snapper. And you can count them. We can count them.
What's the scale, Steve?
This is about 4 meters, amberjack. It's about 4 meters across. That's good.
What's the GPS of that location?
I'll show you. Now watch this animal here. He sees the green laser. He's following it. So one question is, do we attract fish? Until he hits his head on the street. And then we pick him up. I have an idea for new fishing lures. And so it's not only fish we see. So if you saw all those schools of fish and everything, right now I've got graduate students here making themselves blind counting all the fish. There was a workshop that the National Academy sponsored in May on using spin-off military technology to track animals in their environment. And actually, that's a very ripe technology right now. And a bunch of the people that are working in that industry came together at that workshop to talk about things like locating multiple moving targets from a moving vehicle. And that's not as difficult as you think it might be. And actually, they think that number one, the technology is declassified enough from Homeland Security. So that's one of these technologies that's really, So in terms of multiple technologies, video does one thing, but a lot of those fish are up higher than a camera, for example, that might be along those along those reefs. And so the combination of video and acoustics together will actually give us a biomass estimate for things like red snapper. And so I also wanted to show an example of combining technologies that combines a little bit of the acoustic tracking as well as the video tracking. And this is particularly relevant to Felicia. Felicia and Chris Koenig back in 2008 and 9 tagged a whole bunch of fish up along the let's see, the no touch thing, up along the this ridge here in Madison Swanson. So what they did was they took gag grouper and red snapper and put acoustic containers in them. So they had tracking devices up there, and basically we were looking at. So this past May, we put an acoustic tracking device or a locator on the back of the video camera. And we actually found, this was 6 years ago, they tagged the fish. We found 19 of those fish still in the same places where they were. So a really interesting example of trying to understand the biology of animals from these new technologies. Next one. So, and the last point I want to make is on contaminants. This is a very confused situation in terms of I'm trying to understand what's going on. The yellow dots represent all of the Gulf of Mexico oil and gas wells in the system. There's about 4,000 locations. The light gray represents the surface expression of Deepwater Horizon, and the green dots represent all the known natural seeps in the region. So who's responsible for environmental contamination? And trying to figure this out, not during an episode like Deepwater Horizon, but actually trying to figure out the background is enormously important, not only in terms of responding to particular episodes like a blowout, but more importantly, trying to look at chronic versus acute pollution in terms of living resources and other things. So, next one. So the National Academy did a study in 2010, in 2003 in an oil budget. And if you actually look at Deepwater Horizon versus the oil budget that they had, the oil budget had seeps as the major component, but if you add in the Deepwater Horizon, it was about 7 times the oil budget. I can say that budget was based on data from 1990 to 1999, so it's a long time ago in terms of what goes on. We'll just skip the rest of that. And the sort of last point I want to make is in terms of Gulf-wide issues. This is a survey that was done in 1967 and 68 before there were national jurisdictions, looking at the distribution of tilefish in